Select statements can perform arithmetic. In a select expression, column names evaluate to row values. And arithmetic expressions can combine row values and constants together to create new values. We're going to do an example based on chairlifts at ski resorts. Let's say that every lift chair has a number, and it also has the number of single riders and the number of couples riding the chairlift. So this table would describe, for example, that chair 101 has 2 single riders and 2 couples, here shown in green and blue. And chair 102 is 3 different couples, and 103 is mostly single riders. Okay, let's say I wanted to check the total number of people on each chair. I would write select the chair number, and then an arithmetic expression, single plus 2 times couple, which is going to evaluate for each row the total number of people on the chair. So here's a row. This chair has 2 plus 2 times 2 equals 6 people in total, matching this picture. And in fact, it turns out that each row has 6 people in total, just in different configurations, as we can see. Now, at no point in evaluating this select statement did I mix together numbers from different rows. Instead, I computed this output row from this input row, this output row from this input row, etc. And I used the names of columns to select the values in each row and then combine them here with a constant and do some multiplication and addition. Here's a discussion question. Given the table ints that describes how to sum powers of 2 to form various integers, compute the following. Well, before I show you what to compute, let's take a look at this table. So this gives the word names of various integers. It turns out that each positive integer can be expressed as a sum of powers of 2. And in fact, there's only one way to do so for each integer. This table is just enumerating how to express each of these integers as sums of powers of 2, where the first 4 powers of 2 are 1, 2, 4, and 8. So, for example, we can make 7 by adding together 1 and 2 and 4. Or I could make 5 by adding together 1 and 4. So the 4 column either has 0, if 0 isn't included in building up this number here, or it has a 4. And you can probably start to see the pattern of how to construct integers out of powers of 2 just by scanning what's going on in these columns. Okay, so on to the questions. Write a select statement for a 2-column table of the word and value for each integer. So it should say that the value for 3 is 3. And include this value for every element here. And when you're finished with that, write a different select statement for the word names of the powers of 2. So given a table with this structure, how would you build the words 1, 2, 4, and 8, but leave out 5 and 7 because they're not powers of 2? Think about it for a moment, then we'll go through it together. Here's the table of ints. If I start SQLite, I can load that table and look at it using select star from ints. Notice something quite interesting. These rows don't appear in the order that I wrote them out in the first place. When you union together a bunch of select statements, you get no guarantees about the order of the result. That's up to the declarative programming engine, which tries to compute the result efficiently. Now, one thing that union does is it discards repeats. And the way that it discards repeats in some cases is to sort all the rows, to look for whether there's repetition. And that's exactly what happened here. So you can see that it's written all of these in alphabetical order according to the word, which is not what I asked for in the first place, but that's what I got. And this is one of the properties of declarative programming languages. There's no particular procedure that's defined in advance that tells me how to compute the result of unioning together a bunch of select statements. Instead, it's up to the system to create the correct result, and this is the correct result, in whatever way it chooses. And that might involve building the table in a different order than you might expect. Okay, moving on to the question of how to write a select statement that gives the value for each word. Well, I need to sum up all of the numbers in each row, and I do that by using their column names. So 1 plus 2 plus 4 plus 8 as value, and I select these from the ints table. Now, even though these are names that appear in this column, that doesn't matter. It's always the case that a select statement's expression will be referring to column names, these 1, 2, 4, and 8 up here. The second question was, how do I select only the words from the ints table that are powers of 2? Well, in order to do that, I need to write a where clause that's true only for the rows that are powers of 2. And I can find those rows by finding rows where one of these numbers is positive and the rest are 0. One way I thought to compute that was just to add up all of the values in the rows, but divide out 2 here so that it looks more like 0, 0, 1, 1, 0, 0, 1, 1, and divide by 4 here so that these all become 1s as well. Once I've done that, I can check whether exactly one of them is 1 by computing the sum and checking its equality. And there they are, the powers of 2.